Now, dear students, let us take up curve tracing. Curve tracing. You see, whatever we have read till now, we may need some parts of that in this topic tracing of curve. Now, let me begin with tracing of curve for cards and coordinates. We'll do in this semester cards and coordinates only. The following points should be remembered for tracing a curve. Number one is symmetry. See, if all the powers of y occurring in the equation are even, here you have y square, y4, and so on. If all the powers of y occurring in the equation of even, then there is symmetry about x-axis. Symmetry is about x-axis only. For example, if I take a parabola y square equal 4ax, you know the geometry of this, or an ellipse x square by a square y square by b square equal to 1. Even powers of y are present, so this will be having a symmetry about x-axis. Similarly, if you have even powers of x, then it will be having symmetry about y-axis. This is a and this is b. If all the powers of x occurring in the equation are even, then there is symmetry about y-axis. For example, this is one of the examples. X square plus y square equal a square. X4 plus y4 equal 4x square y square. See, if x and y can be interchanged without any change in the given equation of a curve, then there is symmetry about the line y equal x. For example, in this, if you replace x by y and y by x, it is x square plus y square equal a square still. So it will be having symmetry about the line y equal to x. Okay. That is the line passing through the origin and making an angle of 45 with positive direction of x-axis. Whatever line will pass through the origin, it will make 45 degree with the x-axis. For example, x cube plus y cube equal 3axy. You see, when x is replaced by y is replaced by x, there is no change. D. If by putting minus x for x and minus y for y, means if x is replaced by minus x and y is replaced by minus y, the equation of the curve remains unaltered, unchanged, unaltered, then there is symmetry in the opposite quadrants. In one quadrant, if there is some shape of the curve, it will follow in the opposite quadrant as well. For example, x square plus y square equal to a square. You see, this is equation of the circle. You know how circle is transformed or transversed. When x is replaced by minus x and y is replaced by minus y, there is no change. Another is xy equal to a square and etc. Fine. Now, this is one. This is about symmetry. Second is about origin and tangents at the origin. See, whether the curve passes through the origin or not, that is 0 0 satisfies the given equation of the curve. If it does, then we say it passes through the origin. Fine. Now, curve or not. If the curve passes through the origin, then you find the equation of the tangents of the curve you find the equation of the tangents of the curve at the origin by equating the lowest degree term to 0. For example, x cube plus y cube equaled 3axy. Which is the lowest degree term? It is 3axy. Obviously, this equation as 0 0 satisfies this curve, so it passes through the origin. Okay. Now, the curve x cube plus y cube passes through the origin. The lowest degree term in this equation is 3axy, equating 3axy to 0, we get equations of two tangents at the origin. At the origin as xy equals 0, that is x equal to 0 and y equal to 0. Similarly, if we have an equation, say a square y square equal to x square a square minus x square, we find that tangents at the origin are given by a square y square minus a square x square equal to 0. Lowest degree term, this obviously passes through the origin. This is the lowest degree term, and when equated to 0 gives us the two tangents, or a square y square minus x square equals 0, or y equal to plus minus x. These are the two tangents. Obviously, if the origin is a double point, then we can discuss its nature also, as has been communicated to you earlier in previous lecture. Fine. So for tracing up curve, one, we will see the symmetry, whether it's the symmetry in the opposite quadrant, whether it's the symmetric about x-axis, whether it's the symmetric about the line y equal to x or y equal to minus x, or in opposite quadrant. Then we will see whether origin passes through the whether the curve satisfies the origin. Then we can find tangents at that origin, and then nature of these tangents, whether they are node, cusp, or a conjugate point. This is second, page 35. Now let me come to the point of, or let me come to, okay, points. This is 3. This is 3 points of intersection with the axis. Whether the curve intersects any axis, whether x-axis or y-axis, this is to be done. Now, how to do it? Putting y equal to 0 in the given equation, we can find the points where the curve crosses the x-axis. For example, y square a plus x equal to x square 3a minus x. You can draw this curve, but then let me put y equal to 0. What I will get? Y equal to 0 means left hand side is 0. I will get x equal to 0 and x equal to 3a. Fine. So x equal to 0 and x equal to 3 are the 2 points on x-axis. So it crosses the x-axis at 2 points. X equal to 0, 0 and x equal to 3 is 0. Let me show this. Putting y equal to 0, we get x square 3a minus x equal to 0, which gives x equal to 0 and x equal to 3a. y is 0, x is 0 and x is 3a. So pass to the curve, thus the curve passes or crosses x-axis at 0 0, x is 0, y is 0, then x is 3 and y is 0. So these are the points where it crosses. Similarly, if or similarly putting by putting x equal to 0, we will get y. We find the points where the curve crosses y-axis. This is simple. When such points are known, we should shift the origin to these points one by one and find the tangents at these new points. Shifting of origin means you have this point. Shifting on means you take x instead of 3a, you take x plus 3a. Y is 0, you put y plus 0. Means it is x plus 3 and 0. You substitute in the given equation, you will get another equation. Then it is lowest degree term when equated to 0 gives us the tangents. This is shifting. Okay. By shifting the origin, we get easily, sometimes we get these nature of the double points. Fine. Okay. This is it. Okay, now let us come to regions where this is for regions where the curve does not exist. If we solve an equation of a curve for y or x, as the case may be, and find out those values of x lying in a range, say values of x between a and b, for which y is imaginary, then the curve does not exist in the region bounded by the lines x equal to a and x equal to b. You see, for example, okay, let me quote an example. If we have a square y square equal to x square x minus a, fine, this is a curve. And let me put one more thing. Say it is 2a minus x. We see that all the values of x less than a, y square is negative. Okay, let me keep, okay, this much. This is simple. This is y square. If this x minus a is positive, then this is nothing to worry about. We can solve this. But as far as x minus a is negative, means x is less than a. Y square is imaginary then, because y square will be minus of x square, means imaginary part. So negative y is imaginary, means the region does not exist. This is it. So let me write it. Uh, for the curve this, we find that for all values of x less than a, y square is negative. That is, y is imaginary. Pen. Let me change the pen. The curve does not exist for values x less than a. So we have a restriction. This is the region where the curve does not exist. Similarly, for different curves, you will have different things, right? For example, if I had kept 2a minus x over here, then 2a minus x, if it is negative, then we cannot have. Means when x is greater than 2a, we cannot have the region where we can draw the curve. Fine? Okay. Fifth one is asymptotes. Asymptote to n curve. This is already done. So there is nothing to be talked about. Then we have to draw a curve. Finally, we have to draw a curve. We need to we need to find out coordinates. This is it. Let me take some examples. 35, this is page. Is it recording? Is it going on? Yeah, recording is going on. Now page, how much it was? 36. Let me take an example, very simple example. Your y square equal x cube. Draw the curve. Trace the curve. See, you have y square equal x cube. Obviously, even powers of y are there. So curve will be symmetric about x-axis, right? This is first one. Write down. Let me write down. Solution. As only even powers of y occur, so there is symmetry about x-axis. Fine, this is 1, 2. When x is 0, y is 0, so point 0, 0 passes through and this curve passes through the origin. Okay, now curve passes through the origin, so equating the lowest degree term, which is the lowest degree term, which is y square, to 0, we find the tangents at the origin. Find as y square equal to 0. That is y equal to 0 and y equal to 0. These are two real and different tangents. So the point is a cusp. Very simple. That is x axis. Y equal to 0 is x axis. Is the tangent at the origin and the tangents being coincident, there is a cusp at the origin. Fine. Third, putting y equal to 0 or x equal to 0, we do not get any new point, right? But the origin. Fine. Fourth one, for negative values of x, y square is negative, right? Negative values of x, y square is negative, means y is imaginary, so we cannot have negative points. Okay, for negative values of x, that is y square is negative, that is y is imaginary or the curve does not exist for negative values of x. 5.